All right, kiddos. Here again, Mr. Murray himself, Engineer Nelson. Okay, we want to solve long division. It's a math skill that comes up every now and then. So first, we want to introduce a Murray method here called partial quotient. Now, again, vocabulary everywhere. The Maori way, we try to like get past vocabulary hindrances and then just go straight to the skill. So quotient is just the result of division. 5 divided by 2, well, probably 2 remaining 1. But let me take 4 divided by 2 is 2. So 2 is a quotient. 6 divided by 3 is 2. 2 is a quotient. The answer is called quotient, right? And if you do addition, the answer is called the sum. If you do multiplication, the answer to that is called the product. Good. So the quotient of two numbers, that's the answer. 10 divided by 5 is 2, or 10 divided by 2 is 5. Those are the quotient. So again, noisy motorcycle, back to it. So partial division. So we're doing division using partial quotient. So quotient is an answer. So for example, you want to do 54 divided by 2. So why not start by breaking the number, right? So 54 divided by 2 is too big, right? 54 is too big. So okay, let's remove 20 and see if why are we removing 20? Because we have 2 here and we add 0. And then it will easily be 10 twos. We have 10 twos in 20, right? So 10 twos. Again, 10 times 2 in Moreri, we say 10 twos, right? So if you take 2, 2, 2, 10 of them, it means 10 times 2. So that's 10 twos here, and it's 20, right? And if we remove the 20 from the 54, means we've shared the 20 already. So we've shared the 20 and we've gotten 10 twos out of it. So this 10 is our partial quotient. So we already begin to have part of our answers. We can remove 10 twos from 54. And we're left with 34. So 54 minus 20 will be 34. So 34, we remove another 20. So it means we remove another 10 twos. So altogether, we remove 22s. Okay, 10 and 10 is 20. So this is the second quotient. And then lastly, we 34 minus 20, we're left with 14. And the 14, we can remove 7 twos, which is 14. Another 14, which is 7 twos. So if we add all this is what gives us 27. And if you say 26, you're wrong. So it should be 27. Okay, so 27 twos. And there's no remainder, meaning that our answer is just 27. So you're going to say 54. And if you say divided, you write your divided sign. Sorry for that mushy. So 54 divided by 2, our answer will be just 27. So that's our answer using partial quotient. Partial quotient. Now you really have to try another example. You really have to try a lot of examples for you to really master a skill, right? So me just explaining it is not enough. But now let's go back to this again and really understand in Morari what division actually means. So we take 54 items. We can say 54 oranges. We split it to two people. So normally what you do is like you just draw your two stick man. Or I love drawing stick man. So you draw one, and then probably you're gonna make the other in such a way that like this way. Maybe he's facing this way. He's looking at his friends this way. Okay, and then we have to share 54 items. So some of you love doing counting: 1, 2, 3, 4, 5, 6. And then at the end, you're gonna count like how many will be under this stick man, and then it will be 27 each. So that's what it means. But look at division again. We have to understand division. Look at this is just 6. I've done 6 divided by 2. So each of them got 3. So 3 is the answer. But this is one way of looking at it. Like you share the 6 to the two people, share it equally, and then of course you're not cheating anybody evenly, right? And you see if it divides evenly. If it divides evenly, it means there's no remainder. Okay, if there's no remainder, then that's exactly the answer. Each of them will get 3. look at another way to get your answer. So if you share, you say, okay, 6 divided by 2, we can reason it out in 2 ways. We are looking at the quotient, which is the result of division. Okay. 6 divided by 2. You take 6 items, you share 1, 2, 3, 4, 5, 6. So that's the sharing action, everyday math. And then you say, oh, each person got what? Each person got 3. Each of them, they got 3, and they should be the same. Then our answer will say is equal to 3. 6, you share it to 2 students or pupils, they each get 3. That's one way of looking at it. Now, what is the other way? The equally important way. In fact, the most important way is even more important when we go down and we do very difficult problems. We're going to ask ourselves 6 divided by 2, not taking 6 items and sharing to 2 students or 2 pupils. We're going to ask ourselves, how many 2's are in 6? How many 2's are in 6? This is because we know if we share like this, we're going to be saying that everybody's going to be getting like this. See, this is 1, 2. Because you want to see what each of them will get. So when you give 1, 2, you count it as 1 because each gets 1, all right? Each of them will get 1. So that is 1, 2. Because you have to make it evenly. You have to share it in this format. And then this way, everybody gets another 1. They get another 1 again. Each, all of these 2 must get 1, 1 each. And then now you see another 1 again. So here there are 3 2's in 6. There are 3 2's in 6. Or if you look at it the other way, meaning that you share and each of them gets 3. So these are the 2 different ways to understand division. Now you take 6 items, you share to 2 pupils, and you see what each of them get. Now we look at these orange one here. We see each of them get, each of them gets 3. So your answer is 3. Or since we are sharing, we look at this one here, the divisor. Look at this here is 2, and we ask ourselves, how many 2's are in 6? How many 2's are in 6? 3. So, and this second way of thinking or looking at division is the most important because it's going to lead us to a very good conclusion called fact families. Now, what are the fact families? It goes like this. 3 2's means 3 times 2. See, 3 2's is going to be 6. We know that. 3 2's is going to be 6. So 1, 2. So that's 1, 2, 2 2's. And then now 3 2's. That is 6, right? And then on the flip side, we're going to commute. This one is going to move to the front. And this is going to move to the back. So we're going to commute means to move. So we're going to commute, we're going to move. And if you do remember your properties, in math jargons, we say commutative property. Means moving property. We can move, we can exchange the numbers, the places, around the operator, the action, the verb. Okay. 2 times 3 means 2 3's. Now your 2 3's, we're going to look at it like this. This is 1 3. Now this is another 3 to make 2 3's. So we see we have 2 things here. 3 2's, 1, 2, 3. And we have 2 3's, 1, 2. But if we add it up, they'll all give 6, right? So 2 3's also give 6. But that is not the end of it. That is not the end of it. Remember, we want to do fact families. Now, if we say 6 divided by 2, our answer will be 3. And again, we will come back and say 6, if we divide it to 3, pupils, sorry about that, 6 divided by 3, and our answer will be 2 to complete our 5 families. Now, but if you simply ask yourself, how many 2's are in 6, will be 3, you see? And you'll not be confused. And then if you ask yourself, how many 3's are in 2's, how many 3's are in 6, the answer will be 2. And you have it here. How many 3? This is all 6. You see, here, this is one group of 6. And this is another group of 6. They're all 6's, right? So now, how many 3's are in 6? So it means 6 divided by 3. Answer is 2. And here we say, how many 2's are in 6? It means 6 divided by 2. And the answer is 3. But now, you see, the second way of understanding division is the most important one. But when you are in nursery 1, nursery 2, class 1, class 2, to just share 6 divided by 2 means you share 6 cocoyams or 6 plantains or 6 oranges to 2 students, you're going to have the answer. But what if I say 100 divided by 2? You don't have all the time of the day to quickly share 100 oranges to 2 students. You're writing like 1, 2, 3, 4, 5, 6 to 100. It's a lot. So what do? We ask ourselves, how many 2's are in 100? And we can easily count. 2, 4, 6, 8. We can count how many 2's. We just keep adding the 2's. This is 1, 2. 2 2's is 4. 3 2's is 6. 4 2's is 8. 5 2's is 10. 6 2's is 12. We can count easily by 2's. And by the time we get to 100, it's 52's. Or you can do repeated division. We can start like, oh, in 10 there are 5 2's. In another 10, there are 5 2's. In another 10, there are 5 2's. And that's 30. In 30, there are 15 2's. Ooh, there are 15 2's in 30. So that is 30. There are 15 2's in 30. You take another 30, there are also 15 2's in another 30. You take another 30, there are 15 2's in another 30, and this is 90, and it's just remaining 10 to make 100, and in 10 there are 5 2's. So 15 2's, 15 2's, 15 2's makes what? 45 2's, and the 5 2's in this one makes 50 2's. So you see, it is easy for us to really ask ourselves, 10 divided by 2, we ask ourselves the reverse question, how many 2's are in 100? Sorry, 100 divided by 2, you say how many 2's are in 100? So again, we're going to go step by step because this is for kids from the 4th grade above. Class 4, if you're class 4 and above, then that's good. Okay, we'll be able to understand this. But again, we have to read so many books in Morori Library. And we have to do a lot of questions and understand meanings of words. Okay, and it will be very, very easy for us to really get by with our division. Now again, don't worry. Some students have been telling me in their school they will give them something like 68,947 like this, and they will ask them to divide this number by 3 like this. And they say that their long division is very hard for them. Right, we take one number each, right? So we ask ourselves, how many 3's are in 6? We have 2 of them because they are directly in 6, so we put above the 2, and we do 2 times 3, and we'll have 6. And we'll do subtraction, right? 6 minus that, and we'll have 0. So we're done with that. And then you have to go and take a lever, and you drop down your 8 to this level. You drop down your 8 down here, right? You can even do this arrow like this, and you bring your 8 now. Now you're working with 8. 0, 8 is just 8, right? So again, you bring it at the same level with 0. So again, and you say, how many 3's are in 8? How many 3's are in 8? Again, you count 3, 6, 9. 9 is already above that. So it's just 3, 6. So that's 2 6's, 2 3's. So 2 times 3. So 2 of that, you have 6. Now you have to subtract it, right? So you subtract it because that gives you that. You subtract it and you have 2 as your answer. And then we're going to drop your 9 to this level to make 29. And then you ask yourself, how many threes are in 29, right? So you can also go by the side and you do repeated stuff like 3. You count another 3. You count until 3 to 29. Or if you can know your 3 multiplication table, you say 1 3 is 3, 2 3 is 6, 3 3 is 9, 4 3 is 12, 5 3 is 15, 6 3 is 18, 7 3 is 21, 8 3 is 24, 9 3 is 27, 10 threes is 30. So that's above 29. So we're going to end with 9 threes, which is 27. So there are 9 threes, right? And then you put a 9 above this. So 9 threes, and you do 9 times 3 is 27. So you see, when you're speaking English and you're solving like this, is very important. We're going to subtract, and of course our answer is 2. And then we're going to drop down this 4 here, and we get 24. And in 24, we exactly get 8 threes. Remember, I was just doing the multiplication table for threes. 8 threes is 24. And you do that, there's going to be no remainder. It's going to be 0. And then you drop down this 7. Drop down this 7, and we'll be working on with this 7. How many threes are in 7? Again, we count in threes. 1 3 is 3, 2 3s, 6. Okay, so we get 6. And then we know that's 2 threes. We put it above there. And 2 threes here. We know our answer is, we're going to displace this. Our answer is 2 threes over there. And our answer is 6. 7 minus 6, and it's 1. So that's your ultimate remainder. There's nothing to drop down. Now look at what we can drop down. You can drop down a 0. There's nothing here. You can add a point. You can add a point here and say this number is 0.0, right? So you also add a point in the answer. And then now you drop down a 0 here. You drop down this 0. So once you put that point, you drop down this 0. Now you have 10. Then how many threes are in 10? We know there are 3 threes in 10. Okay, and then that's already after the point. And then it will be 7. It will be 9, sorry. And then you subtract that, you have 1. You drop down another 0, and then you go to the hundredths place. It will be another 3 again. You have 9. Subtract, you have 1. You drop down another 0, because we can, in the original answer, we can add this many zeros. So you keep dropping down these many zeros. All these zeros after this point, they just mean 0. But because we have different place values, we'll keep having like 3 3 without n. But when you have 3 without n, just put that 1 3 and you write a bar on top of it. This bar is read as recurring with a bar like this. So we have the answer will be, so the question is 68,947.0000, and you divide it by 3, and the answer is 22. You can put a comma, 22,982.3 recurring, 0.3 recurring motorcycle. So again, if you do understand this, fine, but we have to do a lot of practice. It's only practice that can make perfect. Plantains make pepper. Practice makes perfect. Plantains makes pepper. Plantains make pepper. Plantains make pepper. Practice makes perfect. All right. Gary cannot swallow okra soup without pepper. Okay. So we'll end here for today. It's been Murray Enterprises, your teacher, Murray. If you want to see me this night, doing this lesson for your edification. Okay, it's me. It's me. Our office here in Yaoundé. Adios. Okay.